Hey, Algebra 2. We are going into Lesson 9, Radicals and Conjugates. Radicals, fancy word for that symbol. This would be the square root. I can add this, and I would have the cubed root, fourth root, etc. But that would be what a radical is. I also want to point out some of the vocabulary. What's underneath this radical sign is called the radicand. And then the number that is here, let's just say it's a 3 for now. This is called the index. That would be an x. When there's nothing written there, we assume, the index is equal to 2. Okay, so when there's nothing there, we always assume the index is 2. But if there is something there, then we know the index is what's written. All right, opening exercise. The instructions say, which of these statements are true for all a and b greater than 0? Explain your conjecture. So a hint, use some numbers to see if the statements hold true or not. So I'm going to push pause because remember the opening exercise is sort of like a warm-up for you. Let's see what you can do with it. Use some numbers to see if the statements hold true or not. Okay, push pause again and slowly check out the answers that I've given to you, paying special attention to number 3. Okay, then we're going to do a little bit of discussion on the next page. All right, so the first thing I want to point out is just a simple reminder that quantity x plus y squared is not equal to x squared plus y squared. And let's just test that out. If I do x equals, I don't know, 6 and y equals 8, let's try that. So we have 6 plus 8, quantity squared. 6 plus 8 is 14. 14 squared. $196. And then let's try the other one. X squared plus y squared. Let's erase that because it doesn't follow the pattern that I just drew. X squared, so we have 6 squared plus 8 squared. 36 plus 64, 6, 7, 8, 9, 10. Okay, 196 does not equal 100. Okay, just a thing that we need to remember. Hold on a second, there's a typo here where those boxes are. Let me figure out what it is. Ah, yes, this is where I needed to put that radical sign. So here's a reminder that the square root of a plus b is not equal to the square root of a plus the square root of b. Okay, for the same reasons, we can't just split those things up. Gosh, if we just put in some numbers here, let's put in some numbers to try. Let's do a equals 9 and b equals 16. Yes, I did pick squares. So if we have the square root of 9 plus 16, that gives us the square root of 25, which is 5. And let's do the other side. Square root of 9 plus the square root of 16. We have 3 plus 4, which is 7. Those are not equal. Okay, so just like up here, I can't just take that 2 and distribute it. I can't just take this radical sign and break it in half. Okay? All right, our first example. First thing I want to do is point out to you the statement, simplest radical form, which is going to be in a lot of the instructions for your problems. The simplest radical form is when the radicand, which is the expression under the radical sign, has no factor that can be raised to a power greater than or equal to the index, either 2 or 3, and there's no radical in the denominator. So this radicand, okay, I can't find for the number that's underneath there, so for your number, I can't find a factor of that number that can be raised to the power greater than or equal to the index. So if we have an 8, okay, I can't take the square root of 8, but if we break that 8 into its factors of 4 times 2, 4 is really 2 raised to the second power times 2. Okay, this factor right here, I can take the square root of. 2 squared, the square root of 2 squared is 2 square root of 2. So this is the simplest form. Okay, so let's practice that a little bit more with the example 1 problem that we have. So express 50 square root of 50 minus the square root of 18 plus the square root of 8 in simplest radical form and combine like terms. What I always try to do here is find perfect squares that are factors of these numbers. 50 I know is 25 times 2. 18 is 9 times 2. And 8 is 4 times 2. Now, the perfect squares, I can actually take the square root of. So the square root of 25 is 5. The 2 is left underneath the radical sign. The square root of 9 is 3. The 2 is left there. And the square root of 4 is 2. The 2 is left there. Now, because I have square root of 2 for each one of these problems, or sorry, for each one of these terms, I can combine like terms. We treat those square roots sort of as variables. I can't do anything with them, but I can collect them because they are the same. So what this says is I have 5 square roots of 2. I have 3 square roots of 2. And I have 2 square roots of 2. So let's do 5 minus 3 is 2, plus 2 is 4. And I have my answer. Okay, exercises 1 through 5. I'm going to ask you to review them all. They're all different. We're going to work through a few of these just so that you can find all of the patterns. What we have here are some identities of radicals, and we're going to need to know how they all work. So follow along and I'll explain all the identities and then summarize on the last slide. So here, I can actually split up this radical just like that, because 1 and 4 are both perfect squares, and 9 is also a perfect square. And 45 breaks into 9 times 5. So the square root of 1 is 1, the square root of 4 is 2, square root of 9 is 3, square root of 4 is 2, and then the square root of 9 is 3 square roots of 5, left underneath the radical. 1/2 plus 3/2 is 4/2, minus 3 square roots of 5. 4 divided by 2 is 2, minus 3 square roots of 5. Okay, am I in my simplest radical form? I cannot simplify this anything further, and these terms are very different because this has a square root and this does not. Therefore, I have my answer. Let's try the next one. All right, I need to distribute this through. And what we see here is I have 2 times 3 minus 2 times 2. Okay, see what I did there? This gives us square root of 6 minus, here we have 2 times 2 is 4. The square root of 4 is 2. It's in simplest radical form because that square root of 6 cannot be simplified any further. Okay, we just reviewed 2 identities that I'll summarize in the last slide of this section. All right, number 3. You see here I have square root of 3 over 8. The first identity we did, number 1, said that I split this up. Okay, now a no-no is having a radical in the denominator. I'm not allowed to have that. So I can multiply by a version of 1. I'm going to multiply by square root of 2 over square root of 2. That is equal to 1. It's equivalent. So it's a valid move in math. Now do my multiplication of fractions across the top and across the bottom. That gave me a square root of 16, which is very cool. And I am now complete. Awesome. Okay, this next one. I can't have roots on the bottom, and it's cubed roots, which are a little more complicated, not much. We sort of need to know what our cubed roots are, our perfect cubes. Let's see. 2 to the third power is 8. 3 to the third power is 3 times 3 is 9 times 3 is 27. 4 to the third power is 4 times 4 is 16 times 4 is 64. I'm going to use that one. Let's multiply this by the cubed root of 2 over the cubed root of 2, which is equal to 1. So across the top, I get cubed root of 10 over cubed root of 64. Sorry, forgot to multiply that. So on the top, we have left over the cube root of 10 over 4. And we're done. Nice work. Okay, this last one, see if I can do, I'm going to split this up. So I've got cube roots, but underneath, I know one of my perfect cubes is 8. And then x cubed times x squared. Notice, I can take the cube root of that and it's going to be perfect, and I can take the cube root of that and it's going to be perfect. The cube root of 8 is 2, and the cube root of x cubed is x. And what's left underneath the radical is 2x squared. All right, these are the properties of the radicals that you just learned. We're going to continue to use them over and over and over again. So review them, and some things I want to point out. A and B must be greater than or equal to 0. You guys haven't learned how to take the root of a negative number yet. We'll learn that as time goes on. And reminder, B cannot be 0 when it's in the denominator. All right, let's go through this example. Okay, multiply and combine like terms. Then explain what you notice about the two different results. So we need to FOIL these. First, outer, inner, last. Square root of 3 times the square root of 3 is the square root of 9, which is 3. Square root of 3 times the square root of 2 is the square root of 6. First, outer, inner, square root of 6, and last. Square root of 2 times square root of 2 is the square root of 4, which is 2. So our answer is 5 plus 2 square roots of 6. Cool, let's do this next one. Square root of 3 times square root of 3 is square root of 9, which gives us 3 minus the square root of 6 plus the square root of 6 minus the square root of 4, which is 2. These cancel out, and I'm left with 1. Okay? So in the second example above, you just learned what conjugate radicals are because the radicals were eliminated. Okay? And that's the goal. When we do conjugate radicals, we want the radicals to be eliminated. Okay? So what do we notice about this versus this that are different? And how do we get conjugate radicals? Conjugate radicals, it's when things are in the form of square root of a plus b, and then we have the square root of a plus the square root of b, and then we have the square root of a minus the square root of b. It's the same a and b terms under the radicals with a plus and a minus. And then if you start with a minus, you change it to a plus. What polynomial identity is suggested by the product of two conjugates? The difference of two squares, where if we have a squared minus b squared, a minus b, a plus b. Okay, there's no middle terms here. Middle terms cancel out. Okay, this is the only one that we have that focuses on the use of conjugates. We only have 3 more slides, and that's just closing stuff. So let's practice the use of conjugates. We're going to FOIL these, and we're going to notice how the middle terms, the radicals, cancel out. So first is 5 outer plus the square root of 15 inner. Oh, that's minus. So sorry. Plus the square root of 15 minus 3. These cancel out and we're left with 2. First, outer minus 7 square roots of 2, inner plus 7 square roots of 2, and last, minus square root of 2 times square root of 2 is square root of 4. Square root of that is 2. Those cancel out. 49 minus 2 is 47. And this last one, 5 minus 2 square roots of 5 plus 2 square roots of 5 minus 4. 5 minus 4 is 1. Okay, so do we see the difference of 2 squares? I know it isn't as apparent when our final A and B isn't a perfect square, but we would just take the square root of it to put it in the right form. Okay, now we're going to see what conjugate radicals are used for. Remember, radicals in the denominator are not in the simplest form, so we need to get rid of any radicals in the denominator. So I need to multiply my fraction by an equivalent fraction, a fraction that is equivalent to 1. Because I know that it's going to get rid of the radical in the denominator. So let's work through this. I'm going to do the bottom. I need to, I'm going to multiply it out, but you guys need to be able to do this without doing all the math if you're comfortable. So 5 times 5, 25 first, outer, inner, last, okay, collect like terms. 25 minus 4 times 3 is 12. We're left with 13 in the denominator. So let me write that down here before we lose it. And let's do the top. So this is the bottom. I don't know why this is in red now. This is the bottom. Let's do the top, where we're doing the square root of 3 times the quantity 5 plus 2 square roots of 3. Square root of 3 times 5 is just that, 5 square roots of 3. Notice I always write the whole number first, the radical second. And then 2 square root of 3 times square root of 3 is the square root of 9. Square root of 9 is 3. So this equals 6 plus 5 square roots of 3 over 13. Okay, so when you get to your problem set and you get to the first ones like this and you're still not sure what to do, please ask. I would love to explain it again. Okay, the process for simplifying an expression with a radical in the denominator has 2 steps. First, we multiply the numerator and denominator of the fraction by the conjugate of the denominator. That means if you have a radical in the denominator, say it's 2 plus the square root of 4, I don't care what it's over, you're going to multiply by 2 minus the square root of 4 over 2 minus the square root of 4. Always. Okay, and then you simplify the resulting expression, which is sometimes the hardest. And then in closing, radical expressions with the same index. Okay, this is the index. And the same radicand. Combine in the same way as like terms in a polynomial when performing addition and subtraction. So it's like having, okay, these are the like terms because they have the same powers. So you can combine them. Oops, except you have to add them correctly. Goodness. 2 plus 4 is 6. Just like if you had 2 square roots of 3 plus 4 square roots of 3, it's 6, goodness, square roots of 3. All done for today.